In 4.4, we're going to be solving radical equations. For instance, the square root of x equals 3. What number makes that true? 9. Let's make it a little bit harder. Square root of x minus 2 equals 6. 38. 38 minus 2 is 36. The square root of 36 is 6. Okay. What about 4 minus 5x equals 10? That's a little bit harder. Okay, so we need an algebraic way to solve this. If we look at the first problem, what is the opposite of a square root? Squaring. So if I square both sides, then the square root and the squared cancel, and I get x is equal to 9. We can do the same thing on the second one. Square both sides, and that gives me x minus 2 equals 36. And then we add 2, and I get x equals 38. Yeah, not too bad. So same thing on the next one. Square both sides. 4 minus 5x equals 100. Oh, this isn't going to be a very nice number. Let's change this, because I can do that. So we subtract 10, and I get negative 5x equals 90. Divide by negative 5, and x equals negative 18. Easy enough, right? Okay, let's do another one. Square root of x minus 5 equals negative 3. Square both sides, and I get x minus 5 equals 9. Then I add the 5, and I get x equals 14. But something's wrong with this. Let's plug 14 back in and see what happens. So I get the square root of 14 minus 5, which is the square root of 9, which is 3. Oh, good. Is it imaginary? No. If we had x squared equals negative 9, and I took the square root, then we get x is plus or minus 3i. So if you are square rooting a negative, that creates an imaginary number. Okay? But this equation here just has no solution. Why is that, Owen? And why is a square root equaling a negative a problem? Yeah, there's no number. There's no, well, so in this case, something times itself cannot be negative unless you use i's, right? Okay, this is a little bit different. Okay, so let's take the square root of x and consider what are the possibilities. What happens when I square root a big positive number? Square root a big positive number. I get a small number. The square root of 144 is 12. What happens when I square root a really small number, like 1 over 16? So if I square root 144, I get 12. So I took a big number and turned it into a small number. What happens when I square root a really small number? I actually get a bigger number. That's weird, right? What happens when I square root 1? Get 1. So 1 is kind of the turning point. If you square root something bigger than 1, you're going to make the answer smaller. If you square root something smaller than 1, you're going to make the answer bigger. What happens when we square root 0? You get 0. And what happens when I square root a negative? You get imaginary. Which of those answers is negative? The answers. Which of the answers is negative? None of them. Right? If I square root a big positive number, I'm going to get a smaller positive number. If I square root a small positive number, I'm going to get a bigger positive number. If I square root 1, I get 1. If I square root 0, I get 0. If I square root a negative, I get an imaginary, which we can't even graph. Which one of those possibilities is negative? None of them. So this cannot happen. There is no way to use a square root to create a negative number. It cannot happen. Okay? Now, it's not imaginary. It's not like there's an I out there or some pretend number that will do this. It's kind of like saying, what is the answer to that equation? So we have x plus 1 has to be equal to x plus 2. That's impossible, right? If you have some weight and you add 1, and you have the exact same weight and you add 2, when will those be equal? Never. So this is just an example of an impossible equation. That cannot happen. Likewise, this cannot happen. Okay? But sometimes it's a little more complicated than that. Is that impossible? No. Yeah, it looks like it's impossible because it has a square root and it's equal to -2. But if I move that 3 to the other side, now I get the square root of x minus 4 equals 1. Can that happen? Yes, it can. Okay, similarly, what if I had, can that happen? No. When I subtract the 5, now I get the square root of x minus 4 equals -2, and that's impossible. There is no way to square root a number and get a negative. Okay? All right, watch this. I have to do this in my head, so it's a little bit hard. Can that happen? Maybe. Why maybe? It depends on x. If I solve this and I get x equals 10, can that happen? Can x equal 10? Yeah. But what if I get x equals -3? No, it can't happen. So we're going to square both sides. Square the left, square the right. The left side square root cancels, and we get x plus 6 is equal to x squared. X squared. What do I do to solve an x squared? I could use a quadratic equation, or I can move, I have to move everything to one side. I can factor. And anytime you see an x squared, what does that tell you about the answers? There are 2 of them. Right, so there are 2 possible answers in this case. So we're going to subtract x and subtract 6. Okay. Are there 2 numbers that multiply to be -6 and add to be -1? -3. Yeah. -3 and +2. So x minus 3 and x plus 2. So x is equal to 3 and -2. What do you think about those answers? The 3 will work, but the -2 won't. Right? So 3 plus 6 is 9. Square root of 9 is 3. -2 plus 6 is 4, and the square root of 4 is not equal to -2, so that one does not work. Okay? So algebraically, we got a result that doesn't work in the original equation, and that can happen anytime you're solving a square root. Okay, let's do this. See if I can make this in my head. Okay. Square both sides. And I get negative 7x minus 12 is equal to x squared. Move everything to the other side. Now I factor. Are there two numbers that multiply to be 12 and add to be 7? Not 6 and 1. Try again. 3 and 4. You were thinking 6 and 2. Yeah, it's all right. And we get x minus 3, or sorry, x equals negative 3 and x equals negative 4. What do you think about those numbers? Neither one of them work. So algebraically, we generated two answers, but neither of them will work. So this one has no solution. What if the answers were positive 3 and positive 4? Then they both work. So, okay, that's a good question. So why does negative 3 not work? Well, when we stick this in here and stick it in here, I get the square root of something equals negative 3. So no matter what happens in there, it cannot equal negative 3. So it's not the inside that's the problem, it's the other side. All right, now these get more complicated and I don't know how to do them in my head, so I've got to find one. We've covered just about all of them. Well, there we go. Okay. So now I'm going to square both sides. And the left side just becomes 27 minus x. But how do you square x plus 3? Can I just say x squared plus 9? Good. We have to multiply it by itself. And we get x squared, a 3x, another 3x, and a 9. So this is equal to x squared plus 6x plus 9. Okay. Now, I subtract 27, and I add x, and I get x squared plus 7x minus 18. Can you think of two numbers that multiply to be negative 18 and add to be 7? X plus 9 and x minus 2. Did you get it this time? All right, so what are the roots? Negative 9 and 2. Should I just throw out the negative? Not necessarily. I have to look at the original problem. Is negative 9 okay? No. Why? It's still negative after I add the 3. So look right here. Is negative 9 a problem? Yes, because negative 9 plus 3 is negative 6. Okay. Is 2 a problem? No. But what if I had negative 2? That would be okay, because when I plug in negative 2 plus 3 is 1, and the square root can be 1. So don't throw out a number just because it's negative. You have to look at the original. In fact, what if this side was 3 minus x, and I ended up with x equals 7? 7 doesn't work. Even though it's a positive number, when I plug it in, I end up with a negative number. Okay? All right. Nope. Nope. Okay. What about this? Can the square root of 2x plus 12 be equal to the square root of 7x minus 8? Yeah, and both square roots are positive. Can a positive square root equal a positive square root? Yeah. Oh, I don't know. So we just square both sides, and I get 2y plus 12 equals 7y minus 8. And the square roots just disappeared and I solve it. So subtract 2y and add 8. And I get 20 equals 5y, and Moosen figured this out. Y is 4. Do I have to worry about 4 not working? No. If a square root is equal to a square root, then you don't have to worry about trying to force a square root to be a negative number. That's fine. So if my answer was y equals -1, I don't have to worry about it, because there's no way to make this equal a negative number because they're both positive on both sides. If you had this, would that be a problem? No. But what about this? That is impossible. Right? You cannot have, well, unless it's 0. The only time that would work is if you had that. Okay, now for the hard one. It's really not that bad. So, we looked at a square root equaling a number. We looked at a square root equaling a variable. We looked at a square root equaling another square root, and a square root equaling a variable plus a number. And now we have square root equals square root plus a number. And these are the hard ones. Okay? So I need to square both sides. The right side becomes x minus 40. And the left side is the problem, 10 minus root x times 10 minus root x. 10 times 10 is 100. 10 times negative root x is negative 10 root x. And this is the same, negative 10 root x. And what about that one? It's positive root x squared, which is just 1x. Okay. So 100. I have 2 copies of those, which makes negative 20 root x plus x equals x minus 40. So the first squaring that I did got rid of one of the square roots. So I'm halfway there, but I have another square root, so I need to move everything but the square root to the other side, and then we'll square it again. So we subtract 100. We subtract x. Those actually cancel. So I now have negative 20 root x is equal to negative 40. How do I get the square root of x by itself? Divide by negative 20, and I get x, root x equals 2. Now I square a second time, and I get x equals 4. Do I have to worry about this working? Yes. So look back at the original. Would plugging a 4 in cause a problem? 10 minus the square root of 4 would be 8. Can a square root equal 8? Yes. But what if x was 144? That would be 10 minus 12, which is negative 2. Can a square root equal negative 2? No. So we do have to plug it back in to check and make sure that it works. All right, let's do another one of those. All right. Square both sides. So the left side is just v plus 45. And the right side, that's a v. That's v. This is 5v. That is also 5v. And that is 25. Oh, 5 root v, sorry. Okay. So simplifying that, I get v plus 10 root v plus 25. So I subtract v. Oh my gosh, I keep doing that. Those cancel. Subtract 25 and I get 20 equals 10 root v. How about 10? We'll divide by 10. So once again, 2 equals root v. Square both sides, and I get v equals 4. Is that an okay number to plug in? Can I plug a 4 in there and maintain a positive number on the right side? Yeah. So that's the answer. Okay, that's it. Get to work.